Hello ladies and gentlemen. In this video you guys are going to learn how to draw a Bohr model of an atom, explain how cations and anions are formed. You'll also be able to determine the charge of an ion, explain what valence electrons are, and use Lewis dot structures to describe those valence electrons. So we've got a lot to do. Let's go ahead and jump in. So the last assignment, the last thing that we did in class was our sorting activity. I had you guys sort your atom cards however you chose to. You all should have came to the conclusion that you sorted them based on their electrons, how many electrons specifically they had in their shells, how many shells they had, how many electrons they had in those shells. We're going to be learning about how the periodic table is arranged, and it has to do with what you all did in your sorting activity. It has to do with those electrons. So let's just jump right in. So our periodic table, you should have had some kind of sort similar to this. You should have had your first two were hydrogen. They only had one shell or one valence ring of electrons, and you should have had them in order with one electron to start and then two was next. All right, the next one, you should have had 3 protons. Lithium then has 2 shells, and everything in this row has 2 shells. What you should notice, however, is that your number of electrons is increasing. So here we've got 3 electrons total, 4 electrons total, 5, all the way up to 8. Next, after 8, this would be 8 electrons on our outer shell, plus the 2 in the middle would be 10. When we jump down here, notice now we've got a 3rd shell, another electron, and 11 electrons total. So everything in the periods, right, when you go across the periodic table, it has to do with the number of shells that those atoms have. And all of these in that 3rd row have 3 shells of electrons. This is called period 3. The 2nd row of electron, it has 2 shells. That's called period 2. The 1st row has 1 shell of electrons. That's called period 1. So what you should notice then, as you go across the periodic table, as you go across the rows, these are actually called periods. Now, something else you should notice, another characteristic of the periodic table is going down our columns. Now, our columns, we call these groups. And what you should notice, if we compare hydrogen, lithium, and sodium, one thing that you should see that they have in common is their number of valence electrons. Valence electrons, those are the outermost electrons. And if you look, hydrogen's got 1 outermost electron, lithium has 1, and sodium also has 1. Let's go to beryllium. Beryllium has 2 on its outer shell. Magnesium also has 2 on its outer shell. If we skip over here to boron, it's got 1, 2, 3 on its outer shell. Aluminum also has 3 on its outer shell. So what I'm getting at is that this periodic table, it is designed very specifically, and it's based on protons and neutrons, or protons and electrons, I apologize. So we go and go one step further with this, in that we name these groups based on how many electrons they have in their outermost shell and also what they are. So go ahead and write these down on your periodic table in your guided notes. We've got group 1, those are alkali metals. Group 2, these are called alkaline earth metals. That's alkaline. Group 13, so we're skipping all those transition metals for today. We're skipping all these guys here in the middle because transition metals, they kind of do their own thing, and we'll talk later on about that. But anyways, group 13, which is over here, boron. Okay, those are the triels of the boron family. Group 14, carbon family, or tetrals. 15, pinctogens, nitrogen family. 16, chalcogens, oxygen family. 17, halogens, fluorine family. And then 18 are your noble gases. So you need to have all of those names written down on your periodic table. Again, I want you to have this definition. Know what valence electrons are. Those are electrons that are in the outermost energy level. And it says each group has the same number of electrons in their outer energy level except for helium. So helium is the only exception to this. Okay, if we look over here, helium, it's got 2 in its outermost shell, whereas neon has 8. Argon also has 8. But there's a reason for this, okay? The reason is because these shells, there are rules for how many electrons they can have in each shell. So I want to get you all to get this down also in your notes. So each electron shell can hold a certain number of electrons. These are the rules for these shells. Electron shells are filled from the inside out, so we have to start with shell 1 and make sure it has its 2 electrons. Then we go to shell 2, and it can have as many as 8 electrons. Shell 3 can also have 8. We're also talking about noble gases here. Noble gases have a full outer electron shell. So noble gases, those were the very last ones, all right, over here. Okay, their outer shell is completely full. That's why every time you go down, right, we added a row. So if you look at neon here, its electron shell, its outer shell is completely full. We go to sodium, the next element, we've added another shell, okay? So all the other elements have partially filled outer electron shells. You can see that from this picture. You know, aluminum here only has 3 on its outer shell, so it's not completely full. Valence electrons then, outermost energy level, how many electrons there are. And then these are all of our rules. We're just going to be dealing with shells 1 through 3 for right now. We'll get into 4, 5, 6, and 7 later on. They're a little more complicated. All right, so again, the reason why it's arranged the way it is because of the number of valence electrons in each group. Group 1, they all have 1 valence electron. Group 2 has 2 valence electrons. We'll jump, again, skipping these transition metals for today. Group 3, again, this is 13, but we're going to call it 3 for now. That starts with boron and aluminum. They have 3 all the way up to our noble gases, which have 8. So let's jump and talk about ions a little bit. You guys know ions have a different number of protons than they do electrons, and that's what gives them their charge. So ions, they have either lost or gained electrons. They're either positive or negative. If they are positive, that's called a cation, a positively charged ion. The way that I remember that, okay, I think cat has a T in it. Positive, it's like lacrosse, you know, T. So cation is a positive ion, and it's lost electrons. Anions, these are negatively charged ions, and they have gained electrons. So the way I remember this, I remember Leo says Ger. If I lose an electron, I've been oxidized. If I gained an electron, I've been reduced. So oxidized to that positive state, reduced to a negative state. The charge is based on number of protons in an atom minus number of electrons. So in this case, calcium has lost 2 electrons, and it has become cation positive 2. So how do you know then if an atom is going to lose or gain electrons? Well, we have something called the octet rule. It says atoms in the main groups like to either have 0 electrons or 8 electrons in those outer energy levels. So atoms are either going to take or give away electrons in order to do that. For example, sulfur is in group 6. And that 6 is way closer to 8. It's a lot easier for sulfur to gain 2 electrons than to lose 6. So sulfur is actually going to, I'm sorry, I think I just said lose. Sulfur is actually, it's easier for sulfur to gain 2 electrons than it is to lose 6. So sulfur is going to gain those 2 and become 2 minus. So here again is the octet rule for you. If the valence is 3 or fewer, it loses electrons. It becomes a more positive charge. For example, magnesium. Magnesium is in group 2, which 2 is less than 3. So it's going to lose those electrons and become 2 plus. If the valence electrons are 5 or more, it's going to gain electrons, and it gains as many as it takes to get to 8. So for example, fluorine, that's a halogen, that's in group 7. So it only needs to gain 1 electron to get to 8. Therefore, its charge would be 1 minus. So we can do a little bit of practice here with predicting charges in the octet rule. I want you to do this. You can look at your periodic table. I'll do the first one with you. So oxygen. Oxygen is in group 6. And I'm going to go back and verify that. Yeah, oxygen is in group 6 here. And you can look again at this chart. This will help you. So here's group 6. So oxygen then has to gain 2 electrons to get to 8. So that would be O2 negative would be its charge. All right, so the last thing I want you guys to do is learn about Lewis dot structures. So Lewis structures, they are very easy to do, and why they are important is that they allow us to describe a chemical based on its bonding, and they're a lot simpler than drawing out all of those levels, like in a Bohr model that would have every single shell drawn. Essentially, we'll be doing, what we're doing with them is eliminating those lower shell electrons and only looking at those valence electrons. So here's your steps. First, you're going to write the symbol of the element. So if it's carbon, you'll put a C there in the middle. Second, determine the number of valence electrons. So look and see what group it's in. Carbon is in group 4. So start on the right and draw the electron counterclockwise around the symbol. So you're just going to put a little dot for 1, 2, 3, and 4. And again, remember that Lewis dots only show valence electrons. And I did not mean to do that. Let me go back. Okay, only show valence electrons. So here's an example. For nitrogen, it's in group 5. It has 5 valence electrons. So, starting here with 1, 2, 3, 4, and it looks like I skipped that right there, so I should have a little dot there for 5. Lewis dots. So here's another little practice for you in your notes. Draw Lewis dot structures for the outermost electrons for these 3 guys, and you'll need to do this in your notes. Once you have those 3 drawn, you should have something that looks like this. So, and guys, I apologize. I should have fixed this. I said to start with here 1, 2, 3, 4, 1 here on lithium. Neon has 8 valence electrons, so it's got 8 dots. As long as you have your dots on there, guys, it's okay. Like, put them on there. Show me how many valence electrons it has. Again, Lewis dots, it just makes life a lot simpler to show, okay, it's got 2 valence electrons versus drawing out the Bohr models and showing how many electrons are in every single ring. So, that is all I have. You should know how to draw out those Bohr models at this point. Explain what cations and anions are, how they're formed, determine the charge of those, and explain what valence electrons are, and draw Lewis dot structures. You are now good to go and start your assignment on drawing Bohr models and Lewis dots.